Okay, so this is our kickoff night. Maybe I should call it launch night next year. I'll give you an idea of what's in store. We have our keynote speaker, So-Young Yi, the first Korean in space, who's going to give us a talk. And she's so much more than that. We'll have a challenge overview if, I don't know if everybody's looked at the challenges, but get people on the same page, get thinking about what you're going to be hacking on over this weekend. Our sponsors, Ansys and Amazon Web Services, have a talk. And we'll do team formation, right? So hopefully in the time that you've spent since arriving on the floor, you've been socializing, having something to eat, and getting to know each other. This is where you're going to really start pitching your ideas after you've gone through the challenges and gotten some inspiration. Sponsors. This would not have been possible without awesome sponsors. Amazon Web Services, Ansys really pulled in to help us out. UltraSafe Nuclear Corporation. That's a sponsor I'm really excited about because it is such an idea that the time for it has come. Imperia Aerospace, you might not have heard of them, but watch out, they are coming with amazing DIY CubeSat kits for the educational market. Living Computers Museum and Labs down south of here is sponsoring us, and we have some sponsorship from Beto's Books and Cafe. Food sponsors is like my dream team. We're going to be having Pagliacci pizza. We're going to be having coffee from Victrola, the entire hackathon. Jimmy John's is giving us sandwiches. Specialty's got some pastries coming. Delight Bakery, okay, they are my favorite Seattle donuts, bar none. And you saw the guys from Rebel. We've got an awesome cake from Be With Love. Kind is giving us some snacks over the weekend, and got some bagels from Einstein. It's really good stuff. Our partners. Big thank you to our host, Surf Incubator, Seton Grass proprietor over there. This is a great place to hack. This is a great place to be, just when there's events and when your space startup that starts this weekend is looking for a space. Maybe you want to talk to Seton about Surf. Orbital Engineers, Casey. Where's Casey Backus?
He was here.
He was here. Okay, so Casey is our the founder of Orbital Engineers. They have been instrumental in bringing in the manpower, the volunteers to help out make this event happen. Science Partnership Fund, our fiscal sponsors, Space Entrepreneur Seattle. You'll hear a little bit from them. You liked our logos. The branding design is by Eric Chang Studios. Check them out. We've got Vive with a space over there, and Kronos Global Academy. They are actually resident on this floor and have a space that will be available for people to play with VR over the weekend. Okay, so as I said, this is the biggest Space App Seattle yet. And what we're going to do tonight is we're going to get you guys set up to start hacking over the weekend. Tomorrow, that's when hacking officially starts, right? At 9 a.m., that's when folks will open the doors and you can claim your spaces, bring your teams in. If you don't form a team tonight, we will try to get you onto a team tomorrow. We want to see teams in the size of 3 to 6 people, right? 3 just because, we want to have the right number of teams to get through. 6, I've dealt with hackathon teams bigger than 6 there. It can get a little unwieldy, but it can happen. Tomorrow and into Sunday, you'll be hacking like the future of humanity depends on it, which is actually kind of true. And I'll talk a little bit about that later. And Sunday, that's when we're having our demos and awards. Our judges panel is pretty awesome. Thank you to Adam Shafar, who put our judging panel together. We've got folks from Explore, Paul Nish is formerly of Spaceflight Industries, Ray from Blue Origin, Chris Voorhees from Synchronous, formerly of Planetary Resources, worked on every Mars rover ever. It's a really prestigious bunch. So what did I mean about hacking like the future of humanity depends on it? So this guy over here, Ron Garan, he's an astronaut, and he wrote a book called The Orbital Perspective. And he was actually instrumental in the creation of space apps back in 2012. That's when it all started. The orbital perspective was about how you go into space and you've got the overview effect, and a lot of astronauts have talked about that. And for him, one of the key takeaways was that that perspective was something that convinced him the problems on our planet, the problems of expanding human presence, the presence of life out into the solar system, they're solvable. You just need to have the right perspective, share it, have the right data, the right information, the right insights. You bring these things together, the orbital perspective as well as the situation on the ground, and you can effect massive change. And Space Apps started from that basic charter, and it's emerged into a global movement of which you have joined in. You could have stayed home. You could have done anything with your weekend. But you are here because you have the orbital perspective. So, without further ado, it is my great pleasure to introduce our keynote speaker, who will talk about her orbital perspective, Dr. So-Yeon Lee, astronaut, biotechnologist, STEM advocate, space entrepreneur, and all-around amazing person. Why don't you come up?
Thank you very much for your wonderful introduction. Yeah. Hello everyone, so nice to meet you. And I always heard about a hackathon kind of things through the YouTube and Facebook kind of thing, but I've never been in that place. So I'm so honored to be here to meet you. And yeah, it's kind of a little bit more introduction. I'm working with a startup right now, but it's not based in the Seattle, but based in the Silicon Valley. We are doing the satellite Ubering to the people around the world because exactly like Ubering the car, you don't want to having the big, huge kind of headache car. You just want to move without owning and managing it and gas change. It is fun for some people, but not fun for me. So I always use the Uber or Lyft. And I like that, and then somebody want to use the space data and remote sensing data or satellite kind of data, but they don't want to have a headache with the satellite. So we are trying to kind of leasing their satellite, or sometimes leasing each other's satellite, or sometimes we have our own satellite and then leasing the data, kind of things do that. And then when I heard about that idea and when I joined that company, I felt like, oh, how can they think about it? Even if it's possible, but I've never thought about that. And first of all, I'm not a satellite expert, so maybe I couldn't think of. And second of all, even if I was on the satellite, because International Space Station is kind of satellite because flying around the Earth, but I've never thought it that way. And then that's because I really respect the people like you to think about some idea to make things happen, to solve the problem, and that is really honored and wonderful. Whenever I ever talk, nowadays I make my title like the mindfulness from the weightlessness, because some kind of big, huge mindfulness kind of stuck in my head during my weightlessness experience, not because there's no gravity, but because it is the kind of orbital perspective, because I could look down to the earth as a third person. Maybe most of you have a kind of experience. Sometimes you have a really, really serious problem and almost overwhelmed, and then you feel like your soul is out of your body, and then you looking at you as a third person, and hey, Suya, you are in this kind of situation, something is this, and then how and why. And then once you became the third person of you, then problem became a little bit more clear, and then you can be more calm, and then you could see problem a little bit more kind of wisely. And that was really kind of wonderful time. And I learned that kind of thing because when I was up to the ISS, I feel like I'm not a part of the earth, and I can look down to the earth. Wow, that's a place I've been in. I've never thought about I could get out of that. And even if I thought my world is this small, the world isn't too big for me to think about all around the world. And as a person who came from Korea, I felt like my country is huge because that is the country. And it takes almost 4 hours from the all the way south, all the way south to the all the way north of South Korea. For 30 years, I thought it's too far. But I came to US and I studied MBA in UC Berkeley. One day I really want to visit my boyfriend who's living in Seattle, and then driving the car from the San Francisco to the Seattle, 15 hours. That's my longest drive ever in my life. Oh my God, I didn't know that kind of big, huge country. But when I was in space, like look down to the earth, I still remember my colleague, a Russian guy, told me, oh my God, such a cute little country you are from. And then I feel a little bit insulted, but I cannot complain, I cannot kind of frustrating because I saw that country together. And then I knew when you are in up there, so I like that kind of expression, when you are in up there, when I was up there. And one day one Russian guy said, when I was up there, and one of my friends who've never been in space sector, and she asked him directly, up there where? There. There where? ISS, I mean, whenever I say when I was up there, it means ISS. It's among the astronaut, yeah, but not among the people. So that my female friends doesn't like any astronaut who talk about that, but I like it when I was up there. Small little laptop keep telling us where we are above. So sometimes if we are crowded area like Europe, they just call you are above Europe because it's too fast to cross the country. And sometimes you are above China or Russia, that is a huge country, and then they said you are above the Russia or you are above the China because it takes a while. And as a Korean people, as you go up to the space needle, whenever you go, you try to find where's your office, where's your house, oh, there's a Puget Sound, and then I didn't know that, but every single humankind who tried to go up high, they try to find something familiar. And then astronauts the same. Whenever they go up, first thing they want to do is they try to find their own state or city or country. Me too. I'm really looking forward to see my country, Korea. And unluckily, when I opened the shutter and then looked down to the earth, we are flying over the US. So computer said C# in Russian because I was in a Russian sector. And then C#, more than 5 minutes. And then keep calling the ocean. And then kind of Africa, Middle East, and Europe. Russia, almost 10 minutes. Because Russian people put the radar not only inside Russia, but also whole Soviet Union countries. So Russia for 10 minutes. And next is what country? China. So Gitai, another 10 minutes. I'm sick of it. And then finally I knew it because China is my neighbor. So computer said, Gare, it's Korea. Wow, Korea! And then pick up my camera, come back, past it. So sad. Korea and Japan even competing in space because whenever computer call Korea, they cannot call Japan. Whenever they miss Korea, then they call Japan because they call just every 2-3 minutes. So they cannot call both. Oh, and then Russian guy said, such a cute little country you are from. And you better prepare for next time because I should hold my camera when the computer called Korea. And wow, I thought that country is huge. I really want to be the best of my country. That's because I applied for an astronaut selection. I should be the 36,000 candidate to be the first and only Korean astronaut. I feel like I'm the best of best, but that small little country's best is not that big deal as the person who looked down to the earth from the space. And then, wow, that's really interesting. And also, before becoming an astronaut, and then even after becoming an astronaut, maybe astronauts should be some kind of special people or something like that. But you see that even I can be, who cannot be? Because all my friends ignore me. You have your best friend. No best friend admire or respect you, always ignore you. And your sibling always. Still my sister, she doesn't care who I am. Even if everybody call me, oh, Soyeon, first Korean astronaut. My sis. Yeah, she doesn't care. And once I kind of met that lady, anyone knows who she is? Yeah, Valentina Tereshkova. Yeah, right. The very first female in the world who have been in space. Yeah. 50 years ago, almost. Yeah. I thought she might be different animal because hero. And then even in Russia, somebody just see her and then cry, oh my God, Valentina. And wow, she might be born in different way. But on my launch day, honorably, she came on the launch side. Surprisingly, she never told me, and then not many people know that she will come. But she heard that first Korean will be the female, and then she kindly come and cheering me. But look at her face, not the cheering face. And then look at my face, so exciting. And then you wonder why. She loves me. She really likes me, but why? Because she came here not as the first female astronaut, but as my grandma. And then I still remember my mom's face on that day. She even fell down. She even lost her conscience because it looks really, really scary. You saw the Ariane rocket launch, right? What if you put your kids on top of that rocket? Yeah. And then no matter how old you are, as your parents, if you put your kids on top of that fire, you feel like you put your 3-year-old kids on the edge of the bathtub full of the water kind of feeling. And then she came here as my grandma because I'm the exactly same as her granddaughter. Even if she came here to cheer me, but she cannot. She was so worried. And I cannot understand because she flew when she was 26 years old. At the time, we don't have that good technology also. And at the time, nobody knows who will come back or who will not come back. But she thought it's okay because she fly. But it's not okay because her granddaughter fly. And I realized that what kind of astronaut it is, what kind of hacker you are, what kind of CEO somebody, they are all start from somebody's daughter, somebody's grandma. They are all just same humankind. And look around you, and then right now you are all same hackers to compete each other to find a good idea, but we don't know who will be what in 5 years and 10 years. So you should be so nice to everybody. One day, one of you guys will beat the Zuckerberg or Bill Gates or something like that because we don't know. I bet Bill Gates' next neighborhood never know that he will be like that 60 years ago. Just a little kid right next door. Still, some of my mom's friends or mom's neighborhood, when I was on the TV as the final 10 candidate of astronaut, and they met my mom and said, oh, have you ever seen the TV? There's a 10 candidate over there. one girl is exactly like your daughter. Because they never imagined that those kind of little girls can be like that. Yeah. But we are all from that kind of place. And finally, after her so concerned and worrying, I finally had a successful launch. And I went to the space, carry out the 16 different kinds of and 18 different kinds of experiment. Some of the professional, some of the educational. I showed the science teacher. And also, I never forgot about having fun. I want to have a meditation like a Chinese seafood to have inner peace in the middle of the year there. And I played taekwondo, had a third black belt, but I've never playing taekwondo like a Jackie Chan or Bruce Lee. I really want to try the flying kick, but never ever can do that on the gravity because my weight gravity is quite too big to kick the ass. So finally, I can do that. And of course, as the first representative of my country, bring a lot of the Korean cultural and national things and to show our pride. And all the astronauts, we are not only representative of our country, but also representative of the whole Earth. So we really want to do something for the peaceful Earth. And I want to show the one photo to you because it's really right time. Maybe some of Asian people could recognize it. Can you guess where it is? It's a night scene of the Earth, some part. Seoul, yeah. So this is Seoul. And you can see the small little rivers going around. That's the small little part of the small little cute country, as I said. And what is this? Where is this? North Korea, yeah. Even if it's located a little bit south on the border, but it's North Korea. And when I saw that kind of scenery from the space, it's so sad. It is, really. Because if you check the YouTube around the 1960 and 70, any single astronaut who come back from their space flight and have a press conference, they always said that, you know what, if you look down to the Earth from the space, we couldn't see any border between the country. Earth is peaceful, it's a blue kind of thing. And they always talk about a peaceful thing. And during the daytime, you cannot recognize the border, of course. And at that time, even nighttime, they cannot recognize that because at that time, you don't have that good electricity like that. But nowadays, any big, huge developed country or big, huge metropolitan city never sleep at night. And you have a really, really bright scene like that. And you could see the border if your neighbor countries doesn't have good electricity grid. As far as your grid goes, street lights go there, but right next to that total dark. So South Korea and North Korea border is really famous because not many countries neighbor each other that huge different economies. And another one is India, Pakistan also quite clear. And around the California area and the Houston area and Mexico and US also pretty much like that. If you don't have a good electricity grid until the far from the metropolitan city. And why I'm telling you is, at that time I realized that how lucky I am. Because to be an astronaut, I applied at least. And I should compete. And to be a PhD, I should apply for school and study hard. To marry, either I should propose or he should propose me. We should do something, right? But to be born here, I didn't do anything. Half of my part is in my father's body, half of my part was my mom's body. How can I do something to be born over there, right? And then even at the time, as my parents, they couldn't plan anything to have a baby in certain country. Of course, nowadays some parents even plan to born their kids in certain country, but not many, so in general. And then what if I were born here? Can I see this kind of scene from the space? Or can I be the hacker? Or can I be any kind of thing? Can I get an education? And then even, can I survive until this age? So all these kind of things going around in my head. Oh my God. The point we were born is the most unfair things happen. So I know all of you have some complaint about what's your situation, anything about your situation, anything you related, any kind of family thing or personal thing or school thing or career thing. But anyway, if you are right now here for the hackathon or space app, you have electronics, you have internet, if you are always angry about low signal of the Comcast, then means you are much better place than the kids were born there, even other part of the earth. Because we always watching the Facebook, YouTube kind of things. What if humans are only 100 on the earth, half of them are starving, or half of them doesn't have internet? We just having always going through our mind, but think carefully. Only because you were born the where you were born, you got a lot much more things than others who were born not exactly there. And then I always complain about what the little countries do, and then Korean education is not good, and I don't like that politician. Oh my God, government. We always think that way, right? But what if we don't have any country to complain like a refugee? Then it's a different world. And what if we don't have any Comcast to complain? Yeah, what if we don't have any I-5 to complain? Yeah. It means you have a street and avenue and cars and infrastructure. So, oh my God, that makes my world totally upside down. Whatever I complain, it is something I got much better than others. And that is my kind of perspective, overall perspective. And that is what I really want to share with you, because you are here to solve the problem of the earth. Of course, if you are smart enough or you have a skillful, you have an idea, then great. If you want something, if you got huge investment after that, that's great. But keep in mind, you start from the very, very far front than other half of the population in the world, then we have a lot of advantage, then we should think about the people who behind doesn't have that resource, and then how we can help them in our own skill and output of our idea, output of our business. Of course, we cannot help directly like any other billionaire, but at least we can think about it. And if we can't do anything, at least we can grateful for what we already have. That is the starting point, I believe, rather than complaining. So yeah, I really wanna kind of share about that, and I wanna close my talk always with this wonderful mind whose name is Tsiolkovsky. Maybe some of you already know that most amazing rocket scientist in the world from Russia. He was the first person who have a conceptual design of the international space station even before we have a commercial airplane. And he declared that if we really want to get out of the gravity field, we need several step rockets until we didn't have any commercial airplane before. So more than 100 years ago, people, but he think about that, and he said, a planet is the cradle of humanity, but one should not live in a cradle forever. And what a planet means from him is the earth. So the earth is the cradle of humanity. Why? Because we got everything from the earth. Even if we trade with our money, but earth, even soils, air to breathe, water to drink, all the vegetable, we owe a lot to the earth because earth gives us for free. We just only trade among us. So kind of like a baby in the cradle. Baby got everything they need in the cradle without paying, without doing anything, just crying, right? Like we cry, oh, why apple is not ripening? Why sun is not rising? Like exact like us. But why we should not live in a cradle forever? What if you're a baby, or when you were a baby, stay in a cradle forever? Then you cannot be here. We should keep drinking milk still now. We should keep having a diaper. We should still keep crying without talking. So even if a cradle is the most comfortable, you should get out of it. Once you get out of it, it's really tough because you should crawl, messy face because you don't know how to use the utensil, mess, floor because you don't know how to go to the washroom and toilet, you are not good at using it. But it's really hard, but finally, look at you, we are grown up. We can drive wherever you go. We can pick the what food we love. So humankind also, when we leave our own comfortable place, we can grow more, and whenever we challenge ourselves, we have more resource and skill. Like you are from your comfortable place. So many people just want to have a comfortable weekend on the couch watching the TV, but you apply for this to get out of your cradle and challenge yourself and do something. So I'm so kind of proud of you, and I want you to be proud of yourself. And good luck for your hackathon, and thank you very much.
Thank you so much. All right, let's switch up from PowerPoint. Okay, we're going to hand it over to Adam, who's going to walk us through the challenges. I'm not going to go into a whole lot of detail, but just so that everybody knows what they are, and when we break from this presentation, we'll get into pointing up things around. Adam.
Thank you, Mike. I need the little clicker thing. Thank you. All right, so the challenges are in 6 categories. We'll go through each of the 6. So, can you build so there are 3 kind of 4 categories, but we'll get to the asterisks at the bottom there. So the first one, design by nature. They want you to design some sort of free flyer to inspect the outside of spacecraft for orbital debris damage. The idea is that you're using some sort of nature-inspired design, materials, those sorts of things. The second one is a set of humans on Mars. It's pretty open-ended. Again, there's greater depth on the NASA page, otherwise this would be a 3-hour-long presentation that went into the whole thing. Do you know when the next rocket launch is? Actually, I did know when the next rocket launch was. It was 6:45 p.m. this evening, which was the Bepi Colombo launch we watched. For those of you who showed up a little earlier, you got to see the latest ESA mission take off. But a tool to track international rocket launch information is getting more and more complicated to do. And then finally, the 4th challenge is kind of a challenge, kind of a cop-out. It's invent your own challenge. Sounds like fun, with the asterisk that if you do that, you can't go on to the global competition. So 2 teams from Seattle will be advanced to the global competition, unless you did invent your own challenge. So that disclaimer's out there. You can still win one of the local categories, but you can't go to the big show. So do that at your own peril. All right, help others discover the Earth. So this is kind of more of a media manipulation type thing. The first one, Artify the Earth, is an art tool utilizing imagery. 1D, 2D, 3D Go is more of a data visualization type thing. I hope some cool stuff comes out of that one. That's pretty neat. And then Space Apps, the documentary. I have to assume they're referencing Spaceballs in the title. And so this is kind of a meta challenge of creating a documentary about people doing challenges. And so that's that one. All right, volcanoes, icebergs, and asteroids. So this is kind of going back down to Earth a bit. So some disaster-y type thing. So the don't forget the can opener is more of a disaster prep type thing, in case volcanoes, or I assume volcanoes. Spot that fire. So this is a great way to really utilize satellite imagery of different types, different spectra, to help nail down wildfires. They do create a lot of smoke, so generally easy to see, but maybe other spectra helps you to identify where exactly the fire is burning. And finally, hello Bennu. So Bennu is an asteroid that the OSIRIS-REx mission is headed toward. We'll get there soon, and they want you to tell the world about Bennu. Unfortunately, Ryugu didn't make the cut, I guess because that's a JAXA mission. But in this case, NASA's pet asteroid is what we're talking about. All right, what the world needs now is, and so this is more of kind of along the theme of the talk we just had, how to make our world a better place. And so, first one, looking globally, is more of helping the public understand our home planet, whatever aspect of that you may find most compelling. The second one is related to displaced populations, refugees, and can we use satellite imagery to learn something about those population patterns, migration patterns, those sorts of things. And then finally, a health makes wealth. So can you integrate data from NASA and more citizen science data to look at human, animal, environmental? Human may be a little tricky, environmental will probably be a little more straightforward. Icy glares. This is all about polar stuff now. Polar Quest, so it's a game. Small children, so games are good because they don't pay attention otherwise. So, teaching people about how the environment's changing, make it a game, people pay attention, at least for a little bit, until someone wins and everyone gets upset. By cryosphere. So, this is pretty cool. You can really localize the user's experience of I'm here, tell me about how the poles, the ice, those cycles are affecting the location I'm at. And then finally, what everyone likes to talk about is visualize the real implications of increasing temperatures. And that is ice shrinking, ice thickness changing. We just had a new mission launched not too long ago from NASA, designed to do laser altimeter measurements of ice. I don't know if that's generating data yet. It might be. It went into Earth orbit, so it's already up there working. We want to check that out. I think this is the last one. Yep. All right. So now we're looking way out there. The first one on the shoulders of giants. This is Hubble Space Telescope. Use it while it's still around. Yeah, we'll begin moving just for that a little bit. So these ones that we got. Remix the golden record. This is kind of a cool idea. So we don't remember the golden record from Voyager was the record with sounds and some imagery on it telling whoever finds Voyager about the human race. And this is kind of a new take on that. What would you send up today if you were wanting to talk about the human race in an Earth escape mission or a solar system escape mission? And finally, plan a rover mission on the moon. The moon is very trendy and sexy right now. Everybody's doing lunar rovers, so why not do your own? If you don't want to go to the moon, do a virtual space exploration. And so this is one of my personal favorites because we're going to send a lot more robots to places than we are people, and I really want to see what it's like on Mars, but I probably won't ever go. So, really good VR experiences to really bring the celestial bodies, not just necessarily the hard rocky stuff, but even the gassy squishy stuff, down to a place where you can feel like you're immersed in it. All right, that's that. So, we've got signs up that reflect those different categories. If you have an interest in a challenge in a given category, you'll want to congregate around those signs. We've got a little room here, some room back there, in the hall here. You'll see them on the wall. And find like-minded folks who are interested in the same challenges you're interested in if you don't already have a team set up. So, Mike, do you want to say anything or go right into answers?
Let's go right into answers. Saul Martin is here to talk about what they do for simulation and for space.
While Mike's getting my presentation pulled up, I just want to say thanks for having us. My company ANSYS is sponsoring the event because ANSYS is very committed to the space industry. We provide engineering simulation software to many industries, but aerospace is one of the biggest. And so we've got lots of great local customers doing cool stuff in space. And worldwide as well. So ANSYS is a large software company, about 3,000 employees. We're headquartered near Pittsburgh, and started in the nuclear industry, but quickly expanded into aerospace. Been around since the 70s. Probably a large majority of all launch vehicles and satellites have used ANSYS software at some point during the development. But engineering simulation, if you're just not familiar, I'll give a couple examples when my PowerPoint presentation comes up. But when you're building expensive hardware, it's difficult to prototype, to do test runs, and so oftentimes you want it to work flawlessly the first time. And so you do a lot of computer simulated launches before you do your actual launch. You want to make sure your hardware is going to perform as intended. And hopefully it won't blow up on the launch pad. So that's why you do lots and lots of computer simulations before you actually build the hardware. The more expensive the hardware, the more simulation you're going to do before you actually test it. So here are the briefly 3 topics. I'm just going to talk for about 10 minutes and give you an introduction to ANSYS, which I just did. We're sponsoring NASA Space Apps because we love the space industry and we're very involved in it. I talked a little bit about what engineering simulation is. Let me give you an example. I was going to show this cool marketing presentation, but we don't have any sound, so it's ANSYS marketing. But here's one example. When somebody's designing a spacesuit and they want to make sure that the air circulation and the CO2 buildup inside the helmet, for example, don't exceed certain levels. One way is to build many prototypes and test them all, instrument them all up, and measure the actual CO2 levels. But that gets very expensive very quickly, and so you can do lots and lots of computer simulations cheaply with the computer power we have nowadays. And so ANSYS supported this particular project at NASA. Here's another example of where it'd be actually impossible to recreate in a live test environment. And so the only possible solution is to do computer simulations. When you're building a building, building an aircraft, designing a building to withstand aircraft impact, you're obviously not going to be doing too many of these. And so here's just one use case where computer simulations are absolutely necessary. This particular simulation was done by NIST, the government arm, National Institute of Science and Technology, Standards and Technology, that does these types of after-action forensics reviews, and ANSYS simulation is a large part of a lot of these types of forensic studies. Here's another example of where ANSYS was used in that particular recreation of the World Trade Center collapse. It's kind of funny as an engineer to read about conspiracy theories about what actually brought the World Trade Centers down. But when you look at the actual engineering and forensics that were done, the simulations that showed how the fires heated up the floor, weakened the structural components, and brought the towers down, there's science behind it, and that's why the NIST report came up with the conclusions that they did. So we're all here because we're interested in space, and one of the coolest things about space is launch vehicles. So here's a couple examples of where ANSYS is used in the design and simulation of launch vehicles. Propulsion systems. If you want to get into propulsion design, you're going to have to learn a lot about computational fluid dynamics, finite element analysis for structural stress, strain, thermodynamics. And all these different aspects of building a launch vehicle require simulation. So I don't have a lot of time, so I'm just flipping through these examples real fast. Here's a cool local company, MSNW, that designs fusion propulsion systems for space vehicles. Another great sponsor of this event is USNC, Ultrasafe Nuclear Corporation, which is designing not fusion but fission reactors for propulsion of space vehicles. Super cool applications, and simulation plays a big part in the design of these kind of systems. So here's another example of where simulation was used not only in the design, but the forensic studies to figure out what exactly happened when hardware failed. Can anybody point out the flaw evident in this photo of the Challenger launch from January 1986? I like to use this example because the commander of this mission, Dick Scobie, is a local guy from Auburn, Washington, who can point out the flaw. Yeah, go ahead.
The SRB, the puff of smoke from the lower half.
Yeah, so as we all know, if you follow this story, it was a failure of the joint, and particularly the O-rings in the joint of the solid rocket booster. And yeah, this puff of smoke is not a good sign, leading to the eventual failure of that vehicle. So Morton Thiokol was the company that designed that solid rocket booster. They used ANSYS extensively in not only the original design, but trying to figure out exactly what happened afterwards. Here's an example of a CFD simulation of the foam shedding, which caused the problems later with the Columbia disaster. And here's an ANSYS tool called Fluent that was used to model the superheated gases that entered the wing when the carbon fiber of the reinforced carbon tile got knocked off of the wing during launch. A quote from friend Thomas Marcusic at Firefly Space Systems, just endorsing why ANSYS simulation was so necessary for the development of their launch vehicle. And if you want to learn more about ANSYS, check out our website. We're not going to be building a lot of hardware this weekend because we only have 2 days, and hardware takes a little bit longer than that to build. But if you want to learn more about ANSYS and you want to give it a try, go to the academic tab on our website. You can download student version of ANSYS. You can run it on your own machine at home. The student version is free to download and use. There's lots of great educational and training opportunities on our website. For instance, there's a link here to a Cornell University free online class you can take. Super cool class called A Hands-On Introduction to Engineering Simulations. So if you've got time, or you believe that this is your career path in the future to build space hardware, then and you haven't started learning about engineering simulation, I highly recommend this course. It uses ANSYS software for the hands-on examples, and it's a free class, so can't beat that. ANSYS supports a lot of different student teams at universities across the country, but here's a local example. We sponsor and support the Hyperloop team and the Formula SAE team at the UW. The photo on the right is our friend Elon at the UW Hyperloop booth at the competition a couple of years ago. He looks pretty interested in the UW Hyperloop pod. And if you get a chance to meet Vikram Jandal, he's the executive director of the UW CoMotion program, which is a great startup incubator here next on the UW campus. Vikram, before he came to the UW, he was an ANSYS employee, so we've got a great partnership there and try to support all their hardware startups at CoMotion. So if you are involved in a startup and you want to be using engineering simulation software such as ANSYS, We've got a great startup program that we started a couple years ago. We really hold the hands of startups. If you don't have any money, we don't ask for anything. We just support you, get you going. And I'll just tell one quick story. When I was getting my undergraduate degree at Stanford, physics was one of my favorite classes. They didn't have an aerospace engineering undergraduate available at the time I was at Stanford, which was my first choice, having grown up reading science fiction books every day of my life as a kid, and was very interested in the space industry. So I wound up majoring in environmental engineering. But remember my first physics class, my first big midterm, I slept through it. So I was so panicked. I thought my entire college career was going to come crashing down. So I'm sure you all know that feeling, that pity your stomach feeling of when you slept through something really important and you just feel like you want to crawl under a rock. So I called the professor and I told him I was sick. I couldn't make it to the test, which wasn't a complete bald-faced lie because I theorized in my mind, okay, maybe I overslept because I'm getting sick. So he was so gracious. He said, oh, don't worry about it. You don't even have to make up the test. We'll just average your next two test grades, and that'll be your grade for the first test. So I did not, sink my ship by stumbling at first. And so the moral of the story is, we all have ups and downs in our careers, and sometimes fall short of our goals, but the key is just to stick with it. If you've got a dream to be involved in the space industry, just keep working at it and don't give up your dream. So thanks for having me tonight.
Okay, next up is Jyoti Abdullah from Amazon Web Services and the Deep Lens team. Let me get her slides ready.
Hi there, I'm Jyoti, I'm from AWS. How many of you here have heard of Amazon Web Services? Okay. No introduction there. So I'm from this team called Deep Lens. How many of you have heard of Deep Lens? Not bad. So I'm the senior product manager for Deep Lens. I was part of the team that came up with this concept of bringing together a device that can help people learn machine learning through hands-on experiential learning. And so Deep Lens is essentially an educational device. I'll get to it shortly. But essentially what I'm here today is not to talk to you about space, but to talk to you about the tools that you can use for your space journey. Prior to working at AWS, I was working at NASA for a year, where I worked on developing an automatic hands-free oral care device. And before I get into the presentation, I just wanted to share a very short story. So when I was there, it was probably 5 or 6 years ago, and I was much younger than what I am right now. So there was this competition there where you need to pitch a technology. You need to work with a team of scientists and pitch it. And similar to like how you guys are all working in groups, people were coming and pitching in, but I was the youngest among everybody out there. And as usual, when I went on stage, everybody thought, it's just like some girl like who just flew in from India, don't care. And it was very hard for me to find anyone who believed in me and who said, okay, I'll partner with you. It took a very long time. I didn't have any partner. I was left by myself. I was trying to figure out what should I do. Maybe I should change, pivot. Hey, can I participate in yours? Maybe I'll contribute X, I'll contribute Y. People didn't want me in their teams. So it was very hard until I had one of the advisors who believed in me and who said, you know what, your idea sounds very interesting. If you can make it a product, I will fund it. And then the minute I had an investor who was backing in, said even before the product was ready, he believed in that idea, then I had people turn around and say, hey, I am a robotics engineer. Can I participate in yours? I am from Brazil and I know X, I know Y. And it was so amazing to see how quickly people came together to form a team just because I had an investor behind me. Long story short, we did complete. We got a patent for it, and we had like a prototyping and all of that. And I left NASA and I'm working with Amazon right now. So the reason I said this story is to say that no matter what obstacles come in your way, if you believe in your idea, go for it, find the right tools, and very quickly you will see people coming around you to form your own team. Hope that inspired some of you here. But let's get on to the tools that can help you move on with your space journey. So I come from the machine learning team. So what I'm here today is to talk to you about some machine learning tools that are available that you can use to help create new ideas or solve new challenges. And so at Amazon, we've been working with machine learning. So you know the Amazon Go, you know the Kiva, you know the personalized engines. So basically what we did was there are a lot of internal tools that we were using at Amazon that we wanted to externalize it. And so some of them essentially became like quick services, some of them became like platforms, some of them became frameworks that you could use. And that's the motive of my presentation here today, is to introduce you to those ones really quickly. So when you're faced with a problem, you know exactly what tool to use to solve. And if any of you have questions in between, feel free to ask me questions. If you have thoughts on, hey, can I use this to do X or Y? We can have a conversation on that. So the idea behind our machine learning tools is to make machine learning very easy to get into the hands of every developer. And that's also the vision behind the product DeepLens that we built, is to get machine learning literally into the hands of every developer. And so there are three stacks for machine learning that you can use. The first stack is called frameworks, where these are the different frameworks that you have. TensorFlow is one form of a deep learning framework. MXNet is another form of a deep learning framework that you can use to code your machine learning algorithms in. And that's the lowest engine level stuff that you would want to do. And for someone who is working on something like frameworks, you would think about what should be my instances and what should be my teraflops of that instance. And so for such people, we have these EC2 instances where you can just quickly run up a machine. So let's say you have you want an NVIDIA machine, but you don't really have to buy one. Instead, you can go into EC2 and figure out the configuration that you want, and there are already pre-packaged machine learning images that you can just install or configure, and you can start with it. And that makes it really easy for someone who wants to go into the lower level of the engine understanding. And the second stack that we have is the platform stack. And I'll go into some of these services a little bit into detail so you get to know what exactly that does. But right now I'm just giving you an overview. So for the platforms, we have a service called SageMaker, which is essentially an end-to-end machine learning platform that allows you to build, train, and deploy. And why is that really interesting? We'll come to that shortly. We also have Mechanical Turk that you can use if you want to have some manual curation being done for your data sets. Now, I don't anticipate you guys using Mechanical Turk, but there are some really cool stuff you could use even as part of your challenge. And as I was listening to those challenges that were being described, I saw a couple of them that I thought would be really interesting that can intersect with what you guys are doing in the services at Amazon. And then the third layer is the application layer. Application layer is essentially built where it's just an API call. So it's all fully packaged, ready. All you have to do is simply call an API for that service, and then you'll return a response. So some of the application services are classified into either vision or language. So vision will have recognition, image recognition, video. Language has poly, transcribe, translate, comprehend, and lex. And I'll go into what each of these are. Some of them are quite simple to understand, like translate is like your translate, right? Like you have something in one language translated into another. But there are some really cool text to speech and speech to text, which could be really helpful in different scenarios for your challenges. So here's a very interesting use case I wanted to share. And again, what I'm trying to do here is show you different examples that have used machine learning, so that when you look at your challenges, you know the places where you can deploy machine learning and places where it's not really applicable, because machine learning is not magic, right? There are certain specifications where it really works well, and there are some cases where that's probably not the best thing to do. So I'm trying to show you the different use cases, so hopefully it will inspire you to look at how to employ machine learning in your challenge. So at NFL, what they essentially did was they used the different metrics and data points. They had sensors installed, used the different metrics to run machine learning algorithms on the back end to do some analysis and essentially identify an optimized tracking technique. And this, they actually did that on Amazon SageMaker. So when we come to Amazon SageMaker, I'll show you how it's really simple. What are the opportunities you have where, without knowing about SageMaker, without knowing about machine learning, how you can really get up and going. And Formula One Racing is another team that really used Amazon SageMaker, wherein they had 120 sensors, and they used it to generate data points, and that they used it to train machine learning models. Again, machine learning models need tons of data, so these are companies that are deploying sensors to get data set so that they can train deep learning frameworks that work for their use case. And so essentially like predicting race events, extracting some critical information that will lead to better times, and increasing fan engagement in real time. And again, there are tons of customers who are using AWS. You'll also see NASA in there, NASA JPL. In fact, one of the cool experiments we did with them was they had this rover, essentially like a Mars rover, and they used Amazon Greengrass, AWS Greengrass, and used it to deploy some object detection models to the rover. So essentially to detect if there is a person in front and who that person is, and then move around. So let's say if it sees me, and then it will say, oh, this is Jyoti, and it sees somebody else that it doesn't recognize, and it would scream alien. And then it would also have like small other small robots that would crawl, and we set up a huge wall, so it identifies where there are spaces in between the wall, and wherever there was a space, it will try to crawl through it versus other ones. Again, this was being done only using visual technology, so not necessarily using IR or any other detector. You could do using that, but basically we were trying to see how vision could, in correlation with other sensors, of how it can really augment the predictions and detection for blockage prevention. So here, the one that I really spoke about was about when you want something to go into the lower level, you'd use instances. Like for example, you'd either choose machine learning armies, which is the machine learning images. And this is for someone who wants to go into who's comfortable with maybe say creating their own Ubuntu desktop. So maybe this is something that they would be interested in. It probably takes 15 minutes for you to configure and set up. So it's super simple. And if you're running something really hardcore today, you may want to consider either like a P2 instance or a P3 instance. So as you're doing your machine learning, or you're thinking about where should I have machine learning models, there's three specific questions that I would ask you to think is, should you spend your time building experiments or training these experiments where you have to identify an algorithm, build an algorithm, and then train your data set on it? Or do you want to spend your time on training, whereas you're looking at how do I make a scalable training set, tuning my hyperparameters, which essentially would determine how well my algorithm works? Or do I want to spend time on deploying? And what we do at Amazon SageMaker is essentially make that process really simple so that you don't spend your time on identifying which one should I do and spending time on each of those sections. What Amazon SageMaker does is it makes it really easy to build your training set. So you can, let's say you have a set of data set that you have downloaded from the NASA site, or you have, in fact, NASA released a complete 360-degree visualization of Martian environment. So let's say you have some data set already that you can point it to. So now you can just spin up your Jupyter notebook, point it to the data set, and there are already built-in algorithms like object detection, some of the common ones like face detection, image classification, or even word to vec for someone who's familiar with the vectorization. So those are some of the algorithms that are already custom built in, which means that they have been trained and optimized. So all you have to do is spin up or access that algorithm, point your data set, and you can start on your machine learning journey. You will also have the capability to tune your hyperparameters. So you have something called one-click training and hyperparameter optimization. For someone who has worked on hyperparameters or who has worked on building deep learning networks, I can tell you that hyperparameters is more of an art than of a science. You've got to keep experimenting. It's like a black box. There's no cut, copy, paste that I can tell you like, hey, for this problem, this would be your parameters. It's more of an art. You have to try different techniques, different variables for you to identify which one is really best for your use case, what's driving more accuracy, if accuracy is important to you, or if something else is important, does the hyperparameters work for that? And so what we made at in SageMaker, which is really brilliant, is hyperparameter optimization, wherein the system automatically tries to find parameters that are suitable for your use, for your specifications. Now, it could be right, and maybe it could be something that you're not interested in, but at least it's worth a start rather than starting from blind. And then we make it really easy to deploy. So it's just one-click deploy, wherein you deploy it behind an endpoint, and all you have to do is call an API against that endpoint for you to get the prediction. So you no longer have to worry about scaling your deployment. How do I deploy something? What do I put it behind? What should be the server size? You don't have to worry about any of that. It's very simply taken care of. And I think SageMaker is something you guys will really enjoy using as part of your challenge. And these are more slides on how you can use SageMaker, but I think I spoke about most of them, so we'll just skip through it. And here are some customers who use SageMaker. My favorite is Grammarly, where they're using SageMaker algorithms to help improve your text. So basically to have an algorithm to predict or suggest how you can improve your grammar or what you write. So I think it's a really cool one. So I told you about applications, the third layer, where you have something driven by vision and something driven by language. So let's look at vision-based services. So the first one is Amazon Recognition, where it's very simple. All you have to do is call an API. The algorithms are tuned and are perfected and deployed behind the scenes. So all you need to do is call that API. And so it does a couple of things out of the box. So you can use it to detect an object or a scene. Like for example, does your picture or image contain an object of your choice? So let's say I'm interested in detecting if there is a car, and so you can detect a specific label. You can also do facial analysis. You can do a face search and match, which could be used for just like how we do a Google image search, but basically use the face embeddings to find who the person is. And unsafe image detection, celebrity detection, and then if there is some text in a picture. In fact, the celebrity recognition was used in the royal wedding. So they used the service to identify the guests. And as we were looking at videos and as we were looking at images and talking to our customers, we realized that there's a huge problem with videos. Like there's tons and tons of videos that they want to use and apply machine learning for, and how do we go about solving that? And some of the issues were videos, the minute you put a machine learning image behind it, it gets low. The context is lost basically. So let's say you're standing in one frame, and the next frame, the same person's fallen down. If the context is not passed to the algorithm, it just thinks that that person is standing, this person is falling, or this person is on the ground. It doesn't make a contextual understanding that the person who was standing is the person who fell down, and that requires to trigger some medical health action. So we wanted to solve this problem, and what we essentially did was came up with our own set of services for video, wherein it performs, you can feed in a video and it can detect the objects in that particular stream of video, detect the faces. It can also identify parts of or clips of that image that is not safe for viewing, and it also does celebrity recognition. And this, along with another service, which I will talk about shortly, really helped for content creators, essentially where they didn't have to look at every video from start to end. And the next set was about looking at voice and language. These are a couple of other tools that you have. So you can use these tools if you have any sound snippets in your project that you can use. So the first one I wanted to show you was Amazon Polly. Polly essentially converts, or rather it presents your text in a human speech-like format. So it's available in 52 voices and in 25 languages. And the most use cases we have seen for Polly are around education and e-learning, essentially using human-like speech to help people learn in different languages. And in content creation and game development, especially when you combine Polly with another Amazon service called Sumerian, which is your VR and AR capability, that with Polly gives you a complete game that you can build. The next is Amazon Transcribe, where just like the word transcribe says, you could say something and it could be your assistant, personal assistant that will take down your meeting notes. And that's basically your voice to text or speech to text service. And all you have to do is pass your audio snippet to it, and you can get timestamps of when a particular word was spoken. And so that really helps if you want to make subtitles, or even if you want to just convert that into a text and do a sentiment analysis on top of that, for example. These are some use cases where transcribes being used. The most popular is call centers, of course. and some subtitles for video on demand. And this does, the next is translate, and as the name implies, it's translating from one language to another. And there are 12 language pairs which are available right now. It does real-time translation. I think with combining your voice and voice services with some image services, you can build some really cool products. And Amazon Comprehend is the one that would do, it would comprehend, basically understand what is written in those texts. So it's like sentiment analysis, for example. So break it down by word to figure out whether the sentiment is positive, the sentiment is negative, if there are any key phrases, if there is any topology needed, or if there's any hierarchy that you could identify or analyze from your data set. And so those are a couple of ML services, but what I wanted to show was how to bring them all together. So like, let's say for example, you're doing your product, you have and you want to do a product analysis on what customers have as a sentiment. So let's say you have a Twitter stream, you just call it Twitter Stream API and you pass it on to an analytics tool on AWS called Kinesis. And the data that you get in Kinesis can then be, let's say it's all in, you have global customers, so it can translate into into English, a common uniform format, and you can use Comprehend to actually break down to understand the sentiments. Push those sentiments into your S3 bucket. S3 is just a storage container that helps you to store different file formats, and you can then use it against different services. And Athena is a very cool analytics dashboard. So you can use Athena to look at the sentiments that have come through. Now, simultaneously, you also have a call center. So let's say you deploy transcribe against the call center calls that come through. So it converts it into text, and then you can use a Lambda function to do essentially the same thing, translate into a uniform format, and then use that to collect. So no matter where your channels are, even if your channels are distributed, you can still go ahead and get your sentiment analysis. So really quickly, I want to get on to this product, which is the Deep Lens. It's really a small product, you can hold it in your hand, and it's fully programmable, so you can deploy any project of your choice onto Deep Lens. Like let's say you want to do object detection, deploy an object detection model onto Deep Lens. It comes with pre-built models. So these are the models that it comes with. So it can detect objects, activity, face, artistic style transfer, and cat and dog. The hot dog, no hot dog was very famous during reInvent. It's based out of a Silicon Valley sitcom. So it became really famous during our reInvent. So you can deploy all of these to your Deep Lens, and you can also deploy your own models to see it working. Here are some examples what people did with Deep Lens. The first one, where he developed an application called Read to Me, wherein he showed his children's books to Deep Lens and made it read the storybook out for him. So he basically integrated Deep Lens with Amazon Polly, and so it did OCR recognition and then converted that using Polly into a voice. The second one is essentially where he created an interactive device wherein the Deep Lens would ask a question and the child would show a picture card that says, this is the answer. And if that's the right one, Deep Lens would say, bravo. If it's wrong, it will give him some hints for them to pick up. So these are some really cool applications. You can go to community projects page on Deep Lens. You will find all these applications. GitHub is open, so you can look into their code. So that's pretty much about all the tools that I wanted to share. And I'm really excited to see what you build. Thank you.
Thanks. All right. Y'all know what this is? It's an actual image of a protoplanetary disk, planetary formation happening before our eyes. And now it's time for team formation. You've made it to this point. If you need a refresher, go to 2018spaceapps.challenge.org challenges to pick your favorite challenge. As Adam had pointed out, there are posters. One poster over there, another poster on the way to the big classroom in there, and 4 other posters representing the challenges our volunteers will get away. So pitch to your fellow hackers, broadcast your skills, create a team on spaceappschallenge.org. Return to serve at 9 a.m. tomorrow. That's when hacking will officially begin. You can go grab your spaces. And there's a question.
Yeah, so, a question. There's 4 of the challenges that are kind of hardware-based. And, I mean, obviously that, like, you're not gonna be able to build a lunar rover in a weekend. So, I mean, what are the expectations? I mean, like, are they looking for, like, a software platform to control the rover? Are they looking more for, like, a high-level mission design? Or, I mean, because these hardware ones, they're very broad. It's not really clear what they're looking for. Can you give any input?
And that's kind of, so the question was, there's a lot of hardware challenges that are more than a weekend's worth of work. What can you accomplish during the weekend, right? And that's ultimately the test, right? If it's mission design, you can present that. If it's actual hardware, did you have a point?
Last year, it was like 2 hours before pencil was down. I hadn't started working yet. But I basically got a mention for writing essentially an essay on my topic. And with things that do obviously take so long, narrow to a chunk of it, or just even cartoon it, storyboard it out, work down the pyramid in some way. It's all, as far as I could tell, when I looked through all the winners globally, people did lots of, different flavors of that.
Okay. Before we break up, if you parked in the garage and you need a voucher, gets you $5 parking, and come see me for those. There's another question in the back. No, it's okay. You don't have to have them all registered by 9 a.m. tomorrow, but be back here at 9 a.m. Yes.
Second question, AWS being a sponsor, let's say I wanted to train at whatever, not being trained, would I be able to talk to her about getting AWS credits?
So AWS credits are open to 50 hackers, so I think we can accommodate quite a few folks. If you join the Hacker Slack, post into the AWS code request channel, and we will vend out a $50 credit. Okay. There, if you look at Guide for Hackers, right, that went out in the email, that is like our Bible for the weekend. Go dig into it. It's got lots of great stuff. Other great offers from this company called Google, I guess, and Microsoft. There's going to be an offer coming out from IBM. There's other cloud vendors that are kind of getting into the space apps space. But do check that out. If you don't know where it is, go to spaceappsseattle.org and click the button that used to be register now. It's Guide for Hackers.
So we can park in the basement tomorrow?
You can park downstairs tomorrow. Parking is $7 for the whole day. Okay. Any other questions? Okay, this is the moment that you've all been waiting for as we've done our talks during this evening. It's a moment I've been waiting for months. Go. Do amazing. Thank you.